Hi everyone, and welcome to Impi, your friendly catamaran. It's that time of year again. We are doing preventative maintenance on Impi. Many cruisers will say cruising is doing maintenance in exotic location. On Impi we take a different view to this. We select the country and the time to do our maintenance projects so that Impi is good to go. And when we're on the islands, we can focus on enjoying the islands and not be doing maintenance apart from the odd oil change and sort of daily maintenance required on a boat. Now, part of this preventative maintenance is being done here in Australia. People heard that we were going to be stripping our windlass and reassembling our windlass, and they asked me to please share this. We're not great on technical videos. I don't feel a passion in sharing technical videos. It's actually pretty difficult to capture technical videos because it slows the whole process, but I've done this at the request of many of you who have asked me to share it. So guys, it's going to be a little bit on the long side. Just excuse the editing and the video work. I hope it's clear enough for you guys. My aim here is not to supply information for the expert, but to help the common sailor like myself, you guys, how to look after your windlass on your boat, how to do a preventative maintenance task on your windlass. And I'll also try and share some things around the electrical motor that we did on the windlass. I'll include some footage like having a dead short in the motor. You're sitting on an island, you've got no resources, let's say. 1 or 2 tricks to keep the electric motor going. Right guys, so I hope you enjoy. It's going to be long. Just choose the parts you really want to look at, and I hope this is of value to you guys. Right folks, let's start at the top section. Let's remove the bush, the gypsy cover. This is the lock lever. It also acts as a guide. It sort of keeps the gypsy in place. This is the gypsy itself. Well, here's the top cone clutch. Underneath sits the bottom cone clutch. Be careful of those sharp corners on the edge. We don't want to do any damage there. This is the key, which in the slot of the other parts fitting over the key causes them to rotate on a round shaft. A spring washer at the bottom. And now we can see we've exposed the first and very important seal together with the base of the top section. Now the housing is formed so the seal sits above the base floor and is formed this way so debris coming up with the chain does not readily damage the seal. Now as the chain is pulled up, and shown here in my attempt to animate a chain, not too good that is, as it is pulled up along with mud and debris from the ocean floor, most of this is deposited into the lower case of the top housing. Now the base of the gypsy has little paddles on the underside of the outer perimeter, and these help to push the debris around the anchor toward the anchor well. Now this groove seen here assists to guide the chain, but it also serves to release debris build-up under the gypsy. On Impi we used a grinder to make this groove deeper so debris and salt water flows away from the base plate and into the locker easier, and this reduces the chance of build-up and damage to the top shaft seal. Damage to the top shaft seal can result in salt and dirt ingress to the top bearings and eventually into the top flange of the lower section and gearbox. A good practice is to always hose the chain off when lifting it, although this is not always practical. Well, on Impi we have 4 flange bolts that need to be removed. We've made it easier to reach all bolts by adding an access port to the mounting base. There are a few ways to remove the lower box. This is my way. On the Argo quick windlass without the capstan, the vertical shaft sits deep through the bottom of the gearbox, so it can be a bit of a chore getting the gearbox to drop the length of the shaft if it has not been well lubed previously or regularly maintained. A good idea is to use emery paper and clean the lower section of the shaft and lube it before actually removing it, so it assists to slide it down. And presto, successfully removed. I want to disconnect the electric cables. Of course we have made sure to turn off power supply to the unit. Also, 2 nuts hold the electric motor and cover in place. These nuts should allow the starter to free from the box. However, in my case it's a bit frozen, and since I'm going to strip the box entirely, I will get back to it later. Before stripping the box, I want to drain the oil from the unit. We undo the filler cap and empty the contents into a clean container. It should be clean because you want to note how clean the oil is. You want to look for copper or metal particles indicating wear. You want to smell the oil for signs of it being burnt, feel it for viscosity, and so on. Oil tells us a lot about what has been going on in a component. When these units are manufactured, small adjustments are made to make sure the worm and worm gear align in teeth mesh. Unless you see unusual wear, shimming will not be necessary, but do take care if removing this to note the order of any shims present. They may be paper thin, so best to be observant. When cruising on boats, it's not always possible to carry special tools for everything. This means we improvise, and doing so means we take special care. When we're removing the outer cover, we don't want to damage the surfaces that seal them, so beware when doing this. We wiggle the cover a bit to free the worm gear from the worm pinion, feel the bearings, look for improper alignment or other issues. My electric motor is free. As mentioned before, it can be removed much earlier on. We use a knife to cut through the sealant material to release the motor weather cover, giving us access to the bolts on the opposite side worm pinion cover. Now again, observe for any shims that may come out of these areas. Well, I learned the hard way when first stripping the box that some parts here are incredibly sharp and can cut like a knife. So please take care, especially of the worm pinion. Never run your finger along the edge of the worm pinion without caution. All surfaces where seal lips run over shafts should not have deep grooves but feel smooth. Otherwise the shaft needs to be sleeved or the seal spaced out a little to seal on a surface alongside it. Now clean all parts carefully. I first scrape off material and then place emery paper on a flat surface where I can very gently bring the housing to an even clean surface for good sealing. Overdoing this is not good because it can affect the side pressure to bearings, so I pay attention just to keep it very light. by cleaning up and just checking everything fits is good. You may recall 2 years ago our flange had corroded away. The suppliers refused to sell us a separate one. They want us to buy an entire unit. We decided rather to build ours up using molding steel and fiberglass. It has been amazing. And this year I decided to add layers to it and clean it up a bit. Yeah, where there's a will, there's a way. No corrosion and good strength. Well, you'll recall earlier I mentioned bearings may have to be pulled with a puller. Now, sometimes without a proper workshop, we need again to improvise here. Well, I can see some would-be experts cringing right about now. I am not saying you should do this, but I found another shifting wrench quite handy here to at least start the bearing in moving. And here the gypsy bush becomes a handy compromise tool as well. Okay, well, now we are going to start installing these bearings. We will do some without having a hydraulic press on board. Usually one can use a puller tool as a setup, a kind of tool to set up the pulling on of a bearing too. However, if one is careful, the bearings can be put in place using a hammer and flat edge punch. So I like to tap on the collar where ball bearings are not going to take the pressure, so in this case against the shaft. I'm also careful not to damage the plastic dust loop cover between the races. You'll recall in disassembly one bearing came off with the shaft and the other side the bearing remained in the housing. worthwhile mentioning here before putting on gasket sealant is that if the worm pinion and worm gear do not align for some reason on assembly, then these end cover plates will need to be removed again so shim adjustments can be made. Fitting seals has some tricks to it too. Usually seals have a dust cover side and a pressure side. This pressure side has a lip that includes a stainless steel spring to hold the lip with some tension to the sealing surface and always faces toward the oil side of an oil-filled cavity. The weight of oil against it also serves to add pressure to the lip of the seal against the surface. I always picture in my mind the side oil will be on and install the seal spring to that side. When I like to lube the seal lip and surface lightly with a rubber lubricant, it helps the seal get started. I also tighten bolts progressively and opposite one another so the flange pulls in nice and square. Folks, all this is set up in the factory. If you put everything back the way it came out, you probably won't have to mess with it. So I always try to pay attention to details, making sure bolts are evenly tightened, covers pull down well to surfaces, seals entering and moving into position over shafts without undue stresses is all important to me. When bringing covers into place or a flange, I make sure that bolt holes will align as I bring them into position. Now once assembled, I like to paint the items for look and protection, so an aluminium etching primer and enamel paint works well. Now this product here, Tef Gel, is a great lubricant and protection in harsh environments. I carry lots of it on the boat. Whilst expensive, it does a much better job than grease and it makes light of future dismantling projects. Phew, guys, it's a long video. Hopefully I'm doing okay here. One needs to just fast forward or rewind to places of interest. Okay, let's get to the top section. So these units come out standard with one seal. However, I've placed two seals here. The top seal with dust lip facing upward and then the lower seal I swing it around so the oil spring side of the lip faces upward. I do this for double protection and have often found dirt in the lower seal which otherwise would have found its way to the bearing. Circlips, oh man, these can sometimes be such a pain, so do not feel alone in this if it's a mission for you. Our problem has been not having stainless steel, so I highly recommend ordering these in from a bearing company like Saul's Bearings in Queensland, Australia, who can have them with you pretty quickly. Again, I'm improvising by using my gypsy and bush to gently hammer the top section loose. Of course, a slide hammer or other means of loosening would be better. Our great social media mate Chuck Lanta showed me how he managed to extract the shaft on his quick windlass since the shaft through the gearbox was not budging. Removing the top housing circlip allows the shaft with bearings to be pulled upwards and out of the top section. Great job, Chuck. Back on Impi, we've removed the circlip in the housing as well as the circlip on top of the bearings. Thanks to the great folks at the Boatworks who kindly pressed the shaft out for us, made light work of it for us. As sailors, we don't always have access to great facilities like this. Previous occasion, I thought to share some footage from the last time we did this. It just shows alternative methods and it may be a help if you can't get to a press to press the bearings in place. There's always a different way to do things. As previously mentioned, these units come out with one seal, but it is possible to install two thinner walled seals here for added protection. Well, I make sure to tap evenly about the outer seal housing to make sure it does not distort and its final position will be evenly squared to the housing. Presto! Ready to install, I prepare the bed to which the windlass is secured. On Impi, I allow the seeker to stiffen up under its own weight before finally fitting the gearbox and tightening it all down. This way it remains as a nice flexible seal. Okay folks, at this point let me just say that some sailors mostly use grease for this, but I believe Tef gel is longer lasting and due to its tackiness does not slip easily. Some folks also feel not to apply grease to the conical face of the cone, however I always lubricate these parts. A lot of what one believes to be right or wrong here comes down to personal preferences, trial and error. We never, for example, use the clutch lever to freefall the anchor to the seabed, whereas many sailors believe this should be the only method of casting an anchor.
I did it my way.
Well, the choice is yours. We roll it out on the windlass in a controlled manner and prefer to do it that way because our windlass allows for this feature. In emergencies we could freefall the unit and tighten up the clutch pack as we ease off the chain. So inside here these little wires, that wire runs on the inside around here, and I'm going to replace those wires, but they are riveted in over there. I can see that this one has melted. That's no good, that's going to cause a short because it's through the sheet. What I'm going to do is try and open up these little lugs, because I won't have a rivet gun. See, there's actually rivets that go all the way through, and I don't have that tool. So I'm going to try and open the little lugs. That's Anna learning Indonesian in the background, if you're wondering, guys. Yeah, we're getting ready to cruise across to Indonesia later this year, and that's why we're doing all this preventative maintenance. Just as well I looked in here, because we've obviously had a short here. It was a good time to open this. Okay guys, I can't video this very well. It's very difficult to video. It's very small items. But in a nutshell, you open up these little crimps, you can slide the wire in there, you can close the crimps again using pliers, and then you move the wire around to the opposite side and you do exactly the same on the other side. And presto, it's there. Right, because of this symptom I can't see anything obvious, I want to test the armature. I'll do a bar to ground test, and we'll be measuring the resistance of each bar to ground, which is the armature shaft here. It needs to be open circuit, so no continuity is allowed. We keep the black to ground and we move the red probe from bar to bar on the commutator until all have been tested. Now in our case no continuity is detected, so that means we probably don't have any broken or damaged windings. Okay, so the next thing I'm doing here is the 180 degrees test. So I set the multimeter to the lowest value resistance, ohms, which is 200 on my multimeter. I measure all the windings in series, looped all the way around from the commutator bars located opposite each other. Now the important thing here is that the readings remain similar for each. So if these readings go to 0 or vary radically or go to an open circuit, it's an indication of a damaged winding. We test OK here. Okay, so it's looking good so far. The last test I want to do is the bar to bar test, which measures each individual loop, and we want to make sure that whatever reading we get does not vary radically from the next. As the name implies, we are going from bar to the bar next door, all the way around the commutator. Well, okay folks, that's very unlikely to have happened, but thought to share that with you in case you get stuck in a remote spot and want to get the motor running again. A lot of carbon, that means that's the wear on the brushes. The armature. You can see there's a little spring on the end there. The brushes actually aren't too bad. I could clean them up. It looks like one or two have worn differently to the others, which is quite strange. So those are the brushes. And this, by the way, is a contact cleaner. Very dirty stuff, this carbon. Pull that back, be careful because there's actually a cable coming up here. You can see that cable. You want to make sure that goes back in place. Right, I showed it this way for ease of illustration, but if one takes out the two nuts attached to these fixed terminals, you can remove the top and pull out the brushes and replace them with ease. Now make sure to align the brushes attached to the fixed terminals when you reassemble it, and reassemble it the same way. I'm testing the armature bearing, seeing that it runs freely and not damaged. I will want to clean up the commutator bars where the brushes make contact. This is very important for strong motor performance. So we are improvising again. We don't want to create flat spots and would usually put this on a lathe using a fine emery paper. However, if one takes care doing it by hand, it's also okay. We use a sharp-tipped tool, a thin screwdriver or other tools able to clean out the dirt in the grooves between the commutator bars. That's nice and clean. I'm just going to put this on loose for now. Right, and then I'm going to put in my... At this point I'm going to insert the brushes, making sure the brush cable terminals attach in a way that allows the cables to move freely. It's important to make sure the spring has a good seating in the groove at the back of the brush, and good tension to keep the brush firmly seated on the commutator. How cool is this, man? Look at this new... Check, guys. Check. It says Cat Impi, man. And let's see the back of that shit. Ah, check at this. Make some memories, come sailing with us down under cruises. Downunderrally.com. John, you're an absolute scholar and a gentleman, my man.
Cheers, mate.
Hey, mate, you're such a star.
We've got to keep you in style.
That's very exciting. How cool is that, guys? That's so cool, man.
That's from Grotty Yachty, mate.
Grotty Yachty.
Sandra's.
Thank you, Grotty Yachty. Well folks, we hope this video helps out our fellow sailing friends, all of you cruisers out there. Subscribe here to keep in touch with us. We love and appreciate interacting with you all. Cheers for now. Impi out.